All right, guys, so now it's time for us to work on our storage layer. Okay, so before being able to have our consumer created to consume the events, we need to have everything set up to where we're going to save the events, right? And we're going to do this in mini.io buckets. We're going to create Parquet files and everything like this. So now we're going to start to create that layer. So here I went ahead and create that storage folder with 3 files in it: mini.io client, Parquet writer, and test storage. I started recording, but I didn't actually hit the button. So I implemented a couple things already on the mini.io client. So I'm not gonna record it. Let's go through what I've already have, and then we can continue from where we stopped with the actual me doing the code. Okay. So apologies by that, but hope the explanation will suffice now. All right. So the first thing we're gonna do is do all of our imports. We're gonna interact with the Boto3 library, and then here I'm gonna set up the logging. So this logging is very similar to what I've been doing. Now our constructor for the mini.io client, we have the endpoint we're connecting to. In our case, in our Docker compose file is on the port 9000. Access key and secret key here, you're not going to hard code it, of course, but for the sake of our local project, we're doing it here, mini.io admin, but you can outsource it. And the region name. So we define our endpoint, and then we create the client using the endpoint, the access key, secret key, and region name. You see that Boto3 is the same one that we're going to use to interact with S3 and AWS. So that's why that's exactly the same parameters that it expects. Then we log that the client was initialized successfully. So we create a method to check first if a bucket that we're going to try, if a bucket exists, because whenever we're creating a resource, it's a good practice to act defensively and try to check if things exist or doesn't exist first before performing an operation. So here I'm gonna call in this method head bucket. This head bucket method will fetch for the metadata of the bucket, not all of the objects. So it's a quick and light way for us to check uh, if a bucket exists. We'll try to get the metadata from it. If we're able to get a metadata, then the bucket exists. So now we move to the create bucket. So we call our bucket exists. If that's the case, the bucket already exists, we just return true. If that's not the case, then we try to create the bucket using the create bucket method from the Boto3 library. If we're not able to do that, we throw out a client error, and then we say that we failed to create the bucket and return false. Now we'll need to, after the bucket is created, we need to be able to upload a file to it. So we need the path, we need the bucket name, and the object name. That could be optional. If we don't have an object name, we're gonna get the name from the object, from the file that it belongs to, and then we'll try to run the method upload file to the path and the bucket name and with the object name, and we log it that we're able to do it and return true. Otherwise, we'll return false that we're not able to upload the file. So this is where I stopped. I was supposed to have recorded, but I didn't. But I hope that's clear. Those are simple methods. Okay. Now let's create a method named upload bytes. They're gonna need the bytes in data in bytes, the bucket name, and the object name, and return boolean. All right, so in this method, we're gonna process data in memory and convert to a desired format, which will be Parquet. And then we're gonna upload this directly in memory, without writing to disk first. Okay, so in case you have a real streaming data, we want to do this and not need to save everything to disk and then upload, save to disk and then upload. All right. So there's no disk IO bottleneck in this case. No, we're not dependent on local disk space and limitation, just on memory. We have fewer moving parts of temp files and anything like this. So we don't need to touch the file system in that case. All right. So we're going to try to use the function put object, the bucket name. We have the key, which is the object name, and the body, which will be data. Very similar to what you do in S3, if not the same thing. Uploaded. Let's get the bytes. To S3, which will be our mini IO. Bucket name. Object name. Return true. Otherwise, client error. Uploaded failed. Return false. Okay. Now we're going to create a method for listing the objects. So in case we need to do any kind of data discovery, monitoring data arrival, cleaning up, or doing any kind of archival operation, this list objects will be handy for us, so we can check what's in there. List objects, bucket name, and you're going to have the prefix. And you're going to leave it empty. Let's return a list. Okay. Now, there are some like prefix patterns for our data lakes. So, for example, we can do region US / to regional stuff. We can do date 2025 10/24 for specific date. We can do year 2025, month 10, like any kind of hierarchical partitioning. We can do process, and also can do raw. So we do this prefix to better organize the data in the bucket, okay? So we can list it. So let's do, because we're gonna save the data like this so we can retrieve it. So let's try to get the response. That's going to be our list objects. V2 method. We do the bucket name, and the prefix is going to be the prefix. So we read everything in that prefix. Now, if we have any type of contents in that response, if we don't have it, we're going to say that no objects were found in bucket name and the prefix we're trying to fetch from. Okay, and return an empty list. Otherwise, our object is going to be the key, the object key, for each object in our response content. Okay, and we're going to log this, that we found this amount of objects in our path. Let's return those, which will be a list. Now, if everything goes wrong, we got an exception from the client side saying that we failed to list objects. And then return an empty string. Okay? Now, let's go ahead and write a method for us to delete objects. Bucket name, object name, and return a boolean. Okay, so deletion is very important. And anytime we need to delete objects for compliance, for cost management, if we need to clean up something, we can do it. We're gonna do the delete objects. The bucket name, and what's the object name? Let's log it, delete it, bucket name, object name. Okay, return true. Otherwise, client error, failed to delete. And let me get this. Let's print out the error as well and return false. All right, these are the main functionalities that we need. Okay. Now I wanted to try to implement as a homework, like maybe a method to get out some statistics from our buckets. Imagine that these statistics can help with like capacity planning, cost monitoring, checks, anything like this. So maybe something like this. What I wanted to try to return. Try to return a structure like if we do get statistics. I'll give you the starting. I wanted to return a dictionary where your first step will be this: stats. Try to return total buckets and buckets. All right. Now think about how you can populate it and then return stats. Okay. So if you look into the GitHub repo, you already have the solution, but I keep this as a challenge for you.